Okay.
So which, I'm sorry, 13, 12.8.
No, 12.8.
12.8.
26.
26, okay. Okay. So it becomes inconclusive, right? So what you get when you do the second derivative test, is that what you said?
Right.
Okay.
I mean,
Just the first part, just the first f of x is kind of.
there's no critical point. So what do you?
Oh, there's no critical points.
Yeah. So what do you do?
Oh, do we have an example in 2D where there would be no critical points?
A line.
Okay. Straight line, there would be no critical points there because there's nowhere that it flattens off unless it's entirely horizontal, right? Okay, so how about, oh yeah, that's beautiful. Square roots. What about exponential, right? Because there's nowhere that it bottoms out and it goes forever up in the other direction. So there's a lot of examples that there are no critical points because there's nowhere that could be a candidate for it to have a turning point, right? So it's not surprising that in 3D, the idea seems to be whatever can happen in 2D, it can happen more and freakier in 3D. So we'd expect this to kind of get extended into 3D. So is that what everybody experienced when you did number 26? Right, 26? So you just end up with no critical points?
X, Y, open bracket, X minus Y.
Is that the problem? 26, do you end up with no critical points? Okay. So then do you have anything to check?
No,
Let's see if I agree with you
Like
guys.
a rational
I hope so.
Oh, this is the answer for that.
Can you do it? I mean, the f of x is not.
Oh yeah? Okay. Shoot, I bring it with me, of course. 12A26. Okay. So this is a bit of a nightmare for derivatives, right?
Yeah.
So if you want to get fx, and I would,
distribute the xy.
yeah,
Then maybe break it into two fractions.
so I would leave it like that, and just start attacking this bad boy, right? Using good old quotient rule.
Yep.
So my quotient rule song is top first. I always say that ideal because it rhymes in different ways. I always say that song, but whatever works for you. So of course you take the derivative of the top first. And the part that's got a minus sign, it makes sense that's when you take the derivative of the bottom because the bottom is to a negative power. That's why it's on the freaking bottom, right? So the minus sign should go when you take the derivative of the bottom function. The only problem to me with the quotient rule is which one do I do first? The biggest mistake is people do them in the wrong order. Top first.
Does it matter if, I mean,
Hell yeah, it'll change the sign, of course, since this is a minus. If you do the wrong order, it'll change the sign
but
of
I thought
your
it was just
derivative.
known as high d low, low d high,
Low D
or
high.
No, I
low
did
squared.
all over.
So it's like hot and warm.
Whatever works. Cool.
Because you said derivative first.
Top first. You take the derivative of the top first. So if fx, what's that going to be?
2xy
2xy
Minus y squared.
minus y squared times the bottom minus.
So it's minus.
2x.
And it's the other one.
Or
2x plus y squared.
So now you're doing the bottom 2x, I like it. Leave the top alone. All over the bottom squared.
Would it be wrong to, no, that would be wrong.
Okay. Anything works better. No. And then what's next there?
Would it be simpler to leave the bottom
Yeah,
as
you
is?
said equal to
Set them equal to zero. You have a minimum, need Fy.
You count that, you count that
Set
bottom
equal.
equal zero, you would never.
So,
Yeah, I'm just saying, would you like square it?
there's no way that it could be undefined,
Okay.
right? So there's no critical points that come from it being undefined. The only way to make it zero is if the top is zero. Right, so however you want to attack this, this is just a place to start here. Doesn't really matter. So if they're equal to each other, obviously it would be zero on the top, right? Then you can multiply through, see if there's any like terms. You'll get 2x cubed y. Oh, this is exciting. So maybe I can, no, I guess not.
Plus 2xy cubed.
Minus 2xy cubed minus x squared y squared minus y4. 2x cubed y minus 2x squared y squared. Alright, so that goes away. I can add the 2x squared y squared over, so I get x squared y squared minus 2xy cubed minus y4 equals 0. So that's what I get from fx. These are all set. Yeah. Alright, so what's the next step?
You take a y squared.
Yeah, y, this could mean that y equals 0, right?
Yeah.
So if I allow for that, then I can kill y squared. And that looks like it might be factorable, right? How are we doing so far, you guys okay? Yeah.
Isn't 2xy times y squared, wouldn't that be a positive 2xy cubed?
Yes.
Oh, shoot. 2xy
Oh, yeah.
plus 2xy cubed, okay. Okay. Alright, thank you. Alright. And then how do you factor that? Or can you?
X, take out x and then it's 1 plus. Wait.
Can you factor this?
Yes. X minus 1?
Yeah.
Yeah, x plus 1, no. Oh, you, no, it's not.
Yes.
Yeah, x plus
No,
y
Factors
okay.
times x minus
Factors in negative 1, they have to be 2, there are none.
No,
Right. Only factors negative 1 or negative 1 and 1, they have to be 0.
Oh.
Yes.
Everything else is right, all the signs. Okay.
And that's just after x.
So that's disgusting.
Oh, that's
And then you need your fy that you might be able to use to help you, right? So for fx, when is it equal 0? When y equals 0 or when this is 0? Right? That's a little too general for us. We can't really do too much with that.
Why is that not a free x squared y squared? You have minus, see where you cross out the 2's, see where the 2's cross cancels?
No, well, you add 2x squared y squared minus x squared y squared makes plus 1 x squared y squared.
Yeah, there's 2 and
Minus 2 minus 1.
2 minus 1.
Well, minus 1, then you're going to add the 2
Add
to
it to
get it to that side. Cool.
Did you factor out the y from the second one? Or the
Yeah,
second
I can
bottom?
factor
Yeah, from here to here, I said y equals 0,
Oh, I couldn't.
and then I can kill it. Yeah, cool. As long as you allow for a variable to possibly equal 0, you can divide by it. All right, so that's as much as we can get from there. Or did anybody get more from that? Which would be neat. I wouldn't do any more with that. No quadratic formula or anything like that. Screw that. So what about fy? So that's going to be equally disgusting, right? So I get, stay with me, x squared minus 2xy times the bottom minus 2y times the top over the bottom squared. And we have the same kind of problem again. We wanna set the top equal to 0.
So what you did off the bat is you set the derivative equal to, the derivative of the numerator equal to the derivative of the denominator, is that what you? I heard it say low D high, high D low or something like that.
That's a saying that, some people use to
Differentiate a fraction.
do the quotient rule.
Yeah.
Yeah.
Excuse
Me, when I was a student, I never did quotient rule. I always brought this up and made it a product rule to the -1 power. Right, and making like denominators wasn't that big of a deal, so I just always, I don't know why necessarily, I just hated quotient rule. I did. Now I like it, it's fine, but to tell you honestly, I never use it still. But by doing that, by realizing the bottom has a negative power, if you brought it up, then the minus sign must be where you're taking the derivative of the bottom. Therefore, what goes first? The derivative of the top. So to me, the form of it, I know, the only thing I gotta remember for myself is top first. Right, there's my song. My song is over really quickly, which is good. No good voice. So, top first. But if the high low thing works for you, I love it. Keep doing it.
Can't we say here that the only way we can get this 0 to be 0 when x and y both be 0, and we can't do that because the function there will be undefined, so, and you can stop there?
So right here, the only way to make this 0 is if x and y are both 0.
Both 0, yeah. So,
And you
we
see
can't-
that, how do you see that?
Because,
X squared plus.
I pretty much stopped at like your first fx, and then I went ahead and did fy instead of equal to each other and tried to simplify from there.
Yeah, I wouldn't try to do too much with this until you get your fy. Because then you're doing a lot of guessing, and I don't really want to work directly with this. So I'm curious what fy looks like and how it's going to help me here. All right. So here we get x4 plus x squared y squared minus 2x cubed y minus 2xy cubed minus 2x squared y. What? 2x squared y squared plus 2xy cubed equals 0. Look okay somewhere.
yeah.
Please double check my exponent
Yeah, okay.
addition. Thanks. Let's see, anything cancel out here? Yes, again, no, I guess not. Wait, here we go. Thank God for that.
And then you can combine.
Put
my
those
terms.
together, x to the 4th minus x squared y squared. What's still there?
Minus 2 x cubed y. That's it. Divided by x squared.
So then if I allow for x to possibly equal 0, then I get x squared, let me move this over here, minus 2xy minus y squared equals 0. That feels very similar to what I got there, right? So I've got this and this as possibilities, right? I've got this, let me write that there. So this is my fy, here's my fx, gives me this. Yes, sir.
Why did you not try the quadratic on that, when you broke it down to, at the bottom, right next to your name? X squared.
There?
Yeah.
Because then the coefficient of this would be 2y, and this would be y squared, and you have to plug that in. You have functional coefficients then. I really try to stay away from that if I can. Not a bad idea. To tell you honestly, it's not that difficult, but why do that when you're going to get more information? Right? If I do that other derivative, I get more information. Now, what's the easiest thing I can do there to help me out to do something?
This is a equation. Add them together.
Add them, because those go away.
Minus 2x.
So I get x minus y, x plus y. Cool. Factor 2, you got a difference of squares. So I get that x has to equal y, or x has to equal -1. How are we doing so far? This is exciting. Yes.
Is that one
Say again?
Is that one gonna be in the exam?
Is that one what?
Gonna be in the exam? That's too long.
So never exactly this one.
So those two are the critical points?
No. Alright, let me see if I can get us to where it's important. So stay with me now. If x equals y, for example, this would become x squared plus, if x equals y, 2x squared minus x squared equals 0. Check me on that.
Cross cancel.
Well, then you get basically you get x equals 0. Cool? Not new. So again, once I get a relationship like this for my system of equations, I do just like we did back in algebra. I just plug them back in, and I seem to be recollecting what I already knew. And if I do it into the other equation for the fy, I'm of course going to get something very similar. I still get x equals 0. And if x equals 0, y equals 0. So now we're finally to that, but I couldn't say that earlier, really. So the only possible thing is 0, 0, but is that in the domain of the function? No. Therefore, the only possible critical point is not even a member of the domain. So how many critical points do we really have? None. So I don't have any reason to do a second derivative test because I have no critical points to check. You with me? So if I'm you, I might be really curious. I know that's not really in the domain, but what does that kind of mean from all this work? What does it mean as in getting close to this? You could look at that if you want to.
Does it mean there's
I thought it meant it had like a flat bottom or a flat top, if it was inconclusive. But
Inconclusive could actually mean quite a few different things. In fact, I think there's one later in this homework that you actually asks you to go further. It says it's inconclusive, but then you have to go into other steps. And let me ask you, here's a really easy example from calculus that was inconclusive. If you want to do the second derivative test, right? Do you guys remember the second derivative test from just straight up single variable calculus? Yeah.
Yeah, I was gonna ask, could you go on, whatever site it was, and do that 3D graph?
Yes, exactly. Cool. So if you want to pay a little bit of money, you get a Wolfram Alpha, then you can sign up for the free trial right now and just do as much as you can, right? And you can put that function in and take a look as you get really close to 0. You can tell it what to put in for x and y.
I was gonna say, does it do like a little black hole thing?
Possibly. But from what your work is showing, it seems like that probably isn't the case necessarily. You'll have to take a look. Cool. Anyway, so for this guy, remember this guy was like extra flat there in a way? You guys remember that? So the second derivative test was inconclusive for this problem, but what can you tell looking at the graph of it? That of course is a location of a minimum. So there should be some kind of visual cue you could do if you have an inconclusive result from a second derivative test for multivariable calculus. There are other ways to still tell what it really is. That test doesn't mean anything definitive. It actually means what it says, inconclusive. We're not sure. Do something else. So in calculus, you do the work. It's inconclusive. You look at the picture. There you go. You're done. Okay.
So what would happen if we had fxx equals 0 and the determinant, the d of xy is positive?
Well, if fxx is 0,
0.
you'll always get negative then. What's true when d is negative?
No, if oh yeah, we'll get to it. Positive. So what's true? It's, oh yeah, okay. I get it.
So in the case where, in this case, the concavity itself came out to be like 0. I mean, at that point, right? I don't know if you guys remember that. That's what I mean by it's like extra flat. Right in that area, it's not even really curved up or concave up or concave down.
It's a hypercritical point.
Okay, cool. I like it. With this guy, how many ways is there for this equal 0? Well, of course, if everything's 0, or this one and this one are 0, right? Or if this equals this. That's the extra weirdness that comes from multivariable calculus. That case is actually really kind of nifty. And you can imagine it's not easy to kind of make a function that has that balance, where these derivatives equal this derivative squared. That's a weird situation. And enough of that side note stuff. Any other questions from?
38.
Is everybody cool with that one? This is actually kind of nice once you get past, well, it's not nice at all. Once you get past this work, you realize there ain't a damn thing to do after that. You're done. There's no critical point. Which one?
38. The same section.
12.8, yeah. Let's see, find the action maximum on the given set. Okay, cool. Oops. On the region x squared plus y squared plus equals 6. Of course, I had to pick a circle that had a irrational radius, but oh well.
That's works out.
38. X squared plus y squared plus equals 6. Yep, cool. 38, right?
Oh, you're a little different from mine.
Oh, do you have the international edition?
It's just flipped. You, they have radical 3x. It's still the same.
Wow, it's really different in yours. You're right. That's nifty.
I don't even see the one you're doing.
Love that. Who else has a different problem for 38? Anybody else? A smaller problem? Okay.
Mine matches.
See me after you, so or during the break. Everybody else has this here for number 38? Do you have a different one? Or do you guys have the international edition or no?
I just rented it from the website you gave me.
Alright.
It's still 12.8, right?
So you got the regular, okay.
Yeah, I have a different one.
Alright. Because they did have, this is the first edition of this book, so they did have some that escaped before they made the final one.
Right.
So there's a problem earlier this semester where they gave us the wrong conditions, and in certain books it was one way, and in another book it was a different way, and they were both the wrong conditions. So it's like, all right, they never quite finished. Anybody else have a question on this specific number 38? If not, then I'll help you guys out.
Yeah, I was just asking during the break.
Any other questions from homework?
I just have I just have like a question. Like during for the exam, you're asked to do f of x, f of y, find out whether there's 0. Use that to solve with like the critical points. And then from there, do the second derivative test to find out. Second derivative test doesn't just tell you if it's a saddle point or if there's a max minimum.
There you go.
What's the difference between them? They give you like a boundary.
Well, if they give you a boundary, that's really the point of this one.
Parametric.
So for this, that's the meat of it. You do it the same way you just said. You do fx, fy, get the critical points, check them in the second derivative test, go to town. So what's left then is this, the boundary. And the way that I showed you how to do that, and I showed you how you have to be careful normally if you do it the way that I showed you. So you could do it the way that they did it in the example, where they took it down to a theta. They took it down to a theta.
Parametric was.
How did you do it?
I just said solve for x squared, and here you can see there's some problems with this because there's an x. So in this specific problem, I probably do the same way they did the example. I wanted to show you a different way that did not include going to a parameter so that you can use what they give you directly. But in this case, I might say, well, hell, it'd be better to go to the parameter because I don't have to worry about, x by itself. Because that would have a plus or minus in there, right? Yeah.
On question number 26, I was thinking if we were to calculate the critical points for a sphere, then we will get a relationship not of points.
Say it one more time for me.
If we were to do this the same procedure for a sphere, then at the end we will get x is equal to y or x equal to negative y.
If we were gonna do that for a sphere, if they gave us an equation of a sphere here,
I mean, if you were to do it, I mean, this one is, I know it's different, but I was thinking instead of we don't have critical point, we have infinitely many critical points. But it's,
you gotta be careful, no. For a sphere, and I kinda see what you're thinking about, but it's not the right setup. It is possible to have ridges, where things happen, right? And I think I laid out an example before, but you can certainly have a problem that goes like this, but then it's like rotated, so you have something like a torus. So where's your absolute max? It actually sits, it's all the points that are on a circle, maybe? You guys with me? So I had this shape, parabola,
That was one of the
and it's like this, right? Where the maximum's gonna be, they're gonna be on a ridge on the top there, it's gonna take the shape of a circle. So you can certainly have locations of maxes or mins that they themselves are equations, because the points, there's so many of them, you have to actually give an equation to just find them. I think that's what you're thinking about. Yes. For a sphere, obviously, there'd be a definite max and a definite min for the whole sphere. Because the max and min is defined to be the largest output and the least output. And there are definitely two poles there for that. But I know what you're thinking. Yeah.
Can you do number 42, please? 12.8.
12.8? So we don't really like this section. Or this is as far as we've made it so far.
Why do you think we're so glad to have the weekend
Yeah.
study?
I understand. I am flexible.
Yay.
As long as you're learning, right?
a big help.
That's totally up to you as always.
You're the same as the professor, you keep on extending the exams and the labs and everything.
No, I don't do it more than once, I'll tell you that. I like to get them done. You said 42? R is on a triangle.
Oh, yeah.
Okay. To tell you honestly, when you first read through this, and then of course if you're in a situation that most of you are, which is you are incredibly new to dealing with this kind of problem, this sounds heinous as hell. You're like, crap, it's in a freaking triangle. How the hell do I do that shit? The circle, I can do the parameter or something. This actually ends up being really nice. So let's see if you guys agree with me.
You can't just straight line numbers.
So if I graph this out for myself, 0, 0, 2, 0. So we're talking about this triangle here, right? So any possible critical points have to exist in or on that triangle. Anything that get critical point, otherwise I can throw out, right? With me? And then I have to check the boundary, which is just 3 very simple lines, right? 2 of them stupid simple. Right, what's the equation of that one?
X equals 0.
X equals 0.
Y equals 0.
Oh boy. Y equals, the slope is -1. Y-intercept is 2.
It's 1 minus x.
Yes, cool. All right, how are we doing so far?
Good.
All right, so now we just attack this thing. How do you attack? What's the first step?
F of X, F of Y.
All right, but do you notice how if they give you a set that's kind of weird, circles we can normally pretty well imagine. If they give me a set defined like this, you definitely want to kind of draw it out for yourself so you can see what's going to go into this, right? So fx
2 times 2.
well, 0 means x equals
1.
fy.
2 1 minus 2.
0, y equals 1. We get one definite critical point. Is it inside the region?
Yeah.
Hell yes. right? 1, 1 is right there. Cool. So then you check that out, right? Yeah, and you're going to throw that into the equation because you want to see what's the biggest and what's the smallest. So f of 1, 1 would equal 1 plus 1 is 2, minus 2 is 0, minus 2 is negative 2. How's that sound?
Yeah, good.
All right, so now you want to check out the boundary. So like for the x equals 0 boundary, you with me? So along x equals 0, what does your function actually look like?
Y
Y
squared
squared minus
minus
2y.
2y.
Yeah. How are we doing so far? That's the most you can do with that, right? That information, x equals 0, therefore, what does your function look like along that line? I desperately want you to really get this. If I plug in any point on the y-axis, I can effectively take x out of the function. That's really all I'm doing very explicitly here. I said that's all that's left over. Right? Okay? And if you kind of look at this, I mean, you could do this if you want to. We can certainly attack this with calculus, but I just wanted to, well, let me look at this anyway. At 0 and 2, and this is an opening up parabola, right? So there's going to be somewhere in there, min, in the middle, and the endpoints are possible maxes. You with me? Okay. How are we doing so far?
Should we take the derivative?
I know. Yes, we should. But I just wanted to show you. And I really don't have to. I don't. I know the critical point is going to be at y equal 1. How do I know that? If it's got if it's got 0 and it's got 2, where's the vertex going to have to be? 1. So if you do the, of course, if you do the, I'm going to write like that even though I really don't have to because it's only got one variable, who cares? You get y equals 1. Right? So then from this work, what point did I get as a possible location of some? 0, 1. Then I have to also check out, now I'm going to check out each one of these points also. Right? You guys with me on that?
Yes.
Along, and this is where, if you really get this, you are right there where you want to be. Along this line, it looks like that parabola sitting over that line. The z's are only related to the y values. You with me? So over this region in the xy plane, there's going to be this parabola. And of course it's going to go below it for a little bit. At y equals 1, it's going to be the minimum, and then it's going to come back up and go up. So in the middle, at y equals 1, I already know there's going to be a location of a possible absolute minimum. I just got to throw it in and see. But the endpoints could possibly be maximums. It depends on how high up they get. So I know from the beginning when I want to check these guys, but I'm also going to want to check where on that line does it reach max or min. So that's why I'm doing this work here. So 0, 1 is another point that I want to check out. What's another point that I want to check out? Y equals 0. The function looks like it's going to be mirror image here, right? Just with x's in there instead of y's.
So 1, 0.
So is it cool? Can you guys see it's going to be 1, 0 if you do the work? If I do that, isn't all the y's going to be x's because of the symmetry of the problem? Let me do the work. If y is 0, I get x squared minus 2x. Fx is 2x minus 2. I get x is 1, so I get 1, 0. Looks like the same work, just with x's instead of y's. This is the kind of place you desperately need to get more comfortable finding yourself, because of symmetry in a problem cuts the work in half. That didn't really cut the work too much, because this work wasn't very long. But you can imagine long-ass problem, and then over here is symmetric. If you don't realize that, oh shit, you got to do twice as much work as you really should have to, right? Because the symmetry, I should get that answered quickly. And what's the last thing I have to check out? Yeah, what do you get when you let it equal negative x plus 2? What's f become?
X
If I replace
squared
y, yeah, get x squared.
plus x squared minus 4x plus 4 minus 2x
Cool.
minus 4.
Square this. Minus 2x minus twice y, so it'll be plus 2x minus 4. You guys, I mean, that's nothing big. Plug that in for y. Right? So then you get f is 2x squared minus 4x squared. There you go. Because the plus 4 minus 2x plus 2x, they go away. So from this I get x is 1 again. So then y is what in this case? To get x is 1, then y is 1. Cool. So right there in the middle of that line, I get another location of a min or a max. Okay. Very helpful. And again, what does it look like for any inputs over this line? The outputs are going to look like this parabola right there, like a cross section in that direction. It's going to look like that parabola. Opening up, so right in the middle, that should be another location of a possible absolute min.
We've already tested that one.
And we tested that point. Why?
By your
Where?
shoulder. F1.
Oh, here. Yeah, that was a critical point. Thank you. I eventually catch up. Okay, so that's already done. That's cool. So now I just got to see what is f of 0, 1, what is f of 1, 0, and then the vertices. Just do all that, pick off the winners, and you're done. Now the big thing, the big picture to get from this is when they give you a region to work with, sketch it out. Do this normal work first, because you're always checking the meat. And this is really like this, right? So the first thing I do is check out the shaded part by doing fx, fy, all this stuff here. And then you start attacking the boundary points. So this is the natural extension to, what do we do in 2D with absolute maximum? What do you always have to check out when you have some finite interval? You always have to check on the endpoints. How do you extend endpoints into 3D? It'll be like boundary points, right? What's on the exterior. Because now you have more you can play with. Okay, hopeful as always. This problem is really not much more math than you would have known coming in here day one. The actual math, the actual attacking this is not a big deal. I don't even have to tell you about partial derivatives to do this part. If I just tell you, oh yeah, we know this, so then that function becomes this, and now you can use good old Math 180 to attack that. You guys kind of see what I'm saying? The math in this problem is not intense at all. It's just keeping the idea together. What steps are involved? Check the meat first. Make sure that what you get is actually in there. And then you got to check the definition of the boundary, whatever that is. Circle, is it straight lines? What is it? Okay, maybe. No, I just got whatever you say. Okay. All right, so any other questions?
Let's do 3.3.
I think you're right. I want to do that.
Well,
We'll do this. We'll do 13.3. We'll take a break. We'll come back and finish out 13.4. And I'll give you what I got.
And review Wednesday.
Review will be Wednesday. I'll tell you what though. Anybody okay with taking a break right now?
Yeah, that'd be good.
Is that okay? Because I can get a better marker. Yeah. And I can get that copies of the homework answers that I left in my office. Okay.